So this is letter D, and we saved this one because we're going to have to use the graphing calculator for it, and that's also for the question on the next page. It says the current population of a small town is 4,000 and is increasing at a rate of 5% per year. Another town has a population of 8,500, but it is decreasing by 12% per year due to unfavorable economic conditions. We're going to write functions to model the population of each town where T is measured in years. So in this case, I typically want to use function notation because if I have two equations, having two y equals, it's just kind of hard to tell which is which when I talk about them. So since I have no other identifying information, I'm just going to use A of t and B of t for my two functions. I'm going to use t for time. I could use x. They didn't specify, or no, they did specify. So I have to use a t. A of t, so these are just basic exponential equations. It doesn't say anything about compounding, continuously, or half-life. So I have 4,000. This one's increasing by 5%, so my base is 1.05 to the t. The second one I'm decreasing by 12% per year. So we know when we write the base for that one, we have to do 1 minus 0.12, which is 0.80. So that's my base to the time. So I've done the first part, I've written functions to model. Next it says, during what time interval will the first town have a greater population than the second town? So I'm going to set this up, and I actually want to say here, lesser population. Okay, so I want to change that to lesser. So we're going to do this, and this means that I want my A of t to be less than my B of t. So that's my inequality. And now we're going to write just a little bit of information. We can never use as an explanation on a Regents exam or a test that I use my calculator. That's like saying I used math to do this problem. So what we're going to do now is we're going to specify that we're graphing these two functions in y1 and y2. It's fine that we have different variables. I could write A of t here. I could write it out. So this is an option. I could write it out. I could just write that I put B of t in this spot. I'm not loving the variables being different. As I said, I would not take off for that, but why don't we write them both the same? So I'm graphing them. So let's head over to the graph. Because it doesn't ask me to solve this with algebra, and this is also something that would be difficult to solve with algebra. Especially for this level, because having two exponential functions both with x is a little more complicated than the equations we solved with logs this year. So if I press a zoom 6, which is usually where we start graphing, I'm not going to see anything. And that should be pretty obvious when I look at the information in my equations. So if I'm trying to find these graphs, I can go to a table. And I see when my time starts at 0 that I'm at 4,000 and 8,500, which should make sense. These are y values, so I need to make sure my y's go up in those thousands. I want to see when population 1 is smaller than population 2, so that seems like it's for about the first 4 or 5 years when I look at it. So when I do my window, my x is good, except I don't really want a lot of negative time. So I don't really need to see back to -10. Remember, x is my time. My y values, the 1 starts all the way up at 8,500. And I saw that in my table also. So I'm going to go all the way up to 9,000. And that's just a number I picked. 8,500 would be fine. A little higher would be fine. Anything like that. So then I can see those functions. Remember, we could see nothing before. So what I'm finding to answer this question, so I wrote that I graphed them, is an intersection point. And really, I'm looking for when A of t is less than B of t. So A of t is this one, so I'm looking for this time interval, cut off at 0. So I do a second trace intersect, press enter 3 times, and my rounding says to the nearest tenth of a year. So I write down my intersection. This is not my answer, it's just a step towards my answer. I have 4.3, 4,925.9. So the interval we want is from here to here, right? That time interval from here to here. So written in 3 different ways, just to practice for this question, you would never be asked for all 3. So we're going to go from 0 to 4.3. It's a little ambiguous how they want what notation they want, because they don't want it to be equal to 4.3, but I rounded anyway. So I'm just going to say from 0, because 0 is definitely included to 4.3 with the parentheses. This is, I went out of order, interval notation. Set builder notation is this. And then as a verbal answer, from year 0 to 4.3 years, the population of the first town is less than the second town. So we're going to look at another one of these word problems on the next page. And actually, I think I'm going to do on a different video because it looks like it is missing.